Hello friends, welcome to Sketchup coding tutorials. Today we are going to learn how to animate simple objects in Sketchup coding. And at last you will be able to animate objects like this. So let's directly go to the Ruby code editor for animation. So this is our 3 lines of default coding. Let's suppose view equals to model dot active view. We're going to suppose that we are working on different views for animation, and we are going to update view at each time to do animation. So we are going to add this variable view as model dot active view. At first we will make a road surface for objects, like some objects to move on a surface. So for that I'm going to declare a PTS as points as array. So let's say points 0 equals to let's say minus 3.5, which is the general length of one lane road. So it's just an arbitrary number anyway. So points 1 equals to, let's say it as 3.5 square bracket 3.5 comma 0 comma 0. Then let's say points 2 as 3.5 comma, let's say the length of road is 100, and let's say it's 0. Let's say points 3 as minus 3.5 comma 100 comma 0. Then we are going to make a face. Let's call it as road surface. Road surface, that will be equal to entities ent dot add face from points. Then let's run this program first by pressing Ctrl R, and it will give a road surface. But in practical the road surface is not like this. It's somewhat curved, having a certain slope for removal of water. But since I'm just making this to make you understand, so let's assume the road surface to be horizontal and straight without any slope in it. The second part is, let's make an object like a bus or a moving vehicle. For that I'm going to create a group. Let's say it as group car1. We are going to add it from entities, so entities dot add group. So I just added a car in the name of group underscore car1. Let's define another point as points 2. Let's say the first point equals to 0 comma 0 comma 0. Let's say the second point as 0 comma 4 comma 0. Let's say the third point as 2.5 comma 4 comma 0, and let's say the fourth point as 2.5 comma 0 comma 0. Then we are going to add let's say the base of the car, suppose at face car. So we are going to work on the entities of group car1. So we will add here group car1 dot entities. So before, while we were making a road surface, we were using the model entities, which is called ent. But now here, since I'm working on group car1, so I'm using the entities of group car1 entities. So to make a face of the car, or to make the base of the car, we need to do group car1 dot entities dot add face. From which points? From points 2. So let's run this, and it will make, let's say, the base of the car. Now since I'm going to protrude this base upward, so I'm going to push the base by 2 units. Let's run this program again, and it will protrude outwards. So this will be our first group, and in the similar way we will make another group or another car. Let's copy this selection using Ctrl C command, and let's press Ctrl V to paste this command. And since this is car1, I'm going to make this as car2, and let's change the points as let's say it as -1, let's say as -1 comma 4, and let's do this as minus 3.5, and let's make this as minus 3.5. Okay, now let's name this as face car2, which will be equal to group car2 dot entities add face, and points not points 2, but we are naming it as, let's say, points 3 3. Then we are going to work for point 3. Then we are going to push this face card 2 by 2 units. So let's run this program, and it will again make another object as second group. So by selection also we can see here that if you click on this object, it will remain intact as one group, solid group, and if we select on this object, it will act as another solid group. Now the main part of animation comes over here. So for animation, one new concept you need to know is the concept of looping. For looping, we are going to use a simple for loop. So let's consider there are 10 scenes going there. For example, at this moment the car was here, at second moment it will be somewhere around here, and in second point it will be somewhere around here. So we are going to divide the scenes into 10 number of scenes or 10 number of views. Let's say we are going to iterate it from 1 to 10. This is a syntax for loop, and at last we are going to end this loop using a end command. Then at the middle we need to understand a new method called transformation. So let's write ent dot transform entities. There is a function called transform entities. Now we need to transform the entity by, let's say, a coordinate of 0, I, 0, and which entity we are going to move is group car1. The next step is, let's consider a new view, which is equal to view dot refresh. Now let's do a condition named slip 0.1. So let's first run this program, and then we will discuss why does this work. Let's press Ctrl R, and this object will move from here to here. Since the car has already gone to this place, the car should not be present in initial position. So to avoid that, we go to the model, press Ctrl A and press delete key, and now again come to this code editor and run the program pressing Ctrl R, and this will do the animation for us. Since we don't need these entities anymore after animation, so what we do is we do int dot erase factorial and press Ctrl R to run. So what's the advantage is that at first the model is empty, and when we press the run command, it will do the animation for us and it will stop. But to make you understand, I'm not going to add this command over here since we need these objects while discussing. So let's run this program. So let's understand this. So it will run from 1 to 10. So there will be 10 views. The car's position will be updated. So it will transform the car's position by simply going I units further. So every time it changes its position from the initial position to 0, I, 0, what it does is it will refresh the given view. So initially, if it was here, translates its position by this coordinate, it will refresh its own position. So we will not see the previous view, but we will see a new view in every loop. And what's the time interval for this car to change its position? It's 0.1. If we make it even short, so if we change the time to a very short period and again run the program pressing Ctrl R, it will move the car very fast. So how long you want to slip, it depends on the speed of the vehicle. You can make your own program to choose a speed of the vehicle and desirable time lapse for the animation. So to make you understand how the animation works, I am going to decrease the speed of animation by putting here slip 1, and let's run the program. So you can see how in each step it's changing its position with respect to time. So let's again put here 0.1. Then I'll again add another car. For it I'm going to copy this and I'm going to paste this by pressing Ctrl V. Then I will do another thing. I will, instead of I will give it 10 minus I, and I will assign this name as group car 2. So let's run this animation. Now you can see that the first car is moving from here to here and the second car is moving from here to this position. And what you do is you make a habit of erasing the entities after you finish the animation and run this program. The program will run and again return to its initial position. So this is all about the basic of animation. You can just use this idea to make a realistic animation in your own way. You can choose the velocity of the vehicle, and you can change the you can choose the length of the road, and for complex modeling you can also make a curve of the road, like the horizontal curves or vertical curves, and you can also add the embankments there. You can add super elevation, and also the cambers are to be included, so you can make a totally realistic animation in your own way. For additional information you can go down to the description box, and for any inquiry feel free to comment in the comment box. So keep watching and keep supporting.